please. I'll let me finish up this. Just 1 second.
Coffee really fast then.
That's the danger of meetings that start god awful early. Okay, let's see. So welcome to the combined DNSSD and HomeNet. Your friendly chairs are in just a wee bit of disarray because we forgot to put together chair slides. Let me see. But we're going to work through this.
You should be able to find easily by Google the IETF note well, which is enough to be displayed, no need to be a slide. And the agenda is on the data tracker, so take it simply.
So I'm going to upload my HomeNet slides and just display the note well that I pasted on that. Give me just 1 second for that, and I'll have that up. Just need, it's just so much clicking and mouse work. It's just really annoying. Okay. And then I have to switch it to the other computer because I did it on one. And okay.
Actually, while we're doing this, we don't have a volunteer for minutes, do we?
We do not yet have a volunteer for minutes, so yeah, we need a volunteer for minute. You can do maybe intro of who we've got here, including our illustrious AD.
And our illustrious AD is presenting the note well. Thank you. So, would anyone like to volunteer to take minutes?
This is Stuart. I can take minutes.
Thank you, Stuart. Much appreciated. So there's a Codia MD link from the data tracker, and if anyone else wants to help Stuart out or take notes while Stuart is talking, please go and lend him a hand. That would be helpful.
Okay, and that is the really small agenda. Wow, thank you. And so we're going to be starting with DNSSD, and just a quick status, we do within DNSSD have some drafts that Ted did update. Let's see. And we're going to be starting with Ted, and so I need to pull down Ted's slides so that I can present them.
All right, should I do the intro? Or I guess that was our intro, probably. We've lost your audio, Barbara.
Oh, yeah, I keep muting myself locally. It's easier than trying to find scroll the mouse over to the mute button. So Jabber, you know, we should all be able to monitor Jabber at this point because it's so nicely integrated, and
Yeah,
probably everybody.
I get Jabber script. I'm already in there, and I'll keep an eye on it. And as
Okay.
usual, folks, if you want to, I'll type it in the colon.
And Stuart, will you be taking notes on code MD or elsewhere?
That's actually what I was just looking at. It appears that CodeMD is the tool of choice now. Is that right?
Yes, that would be
Yes.
great. If you could use that, that would be wonderful.
Yes, I've not used this before. It tells me visit/features if you don't know what to do. Happy hacking. It seems like a bit of a text adventure game.
There's an edit button at the top right somewhere.
Okay, I'll figure it out.
Okay, so let me see. Meeting materials. How does this work? Oh, you know, I really should have done the training. Let's see. So I need to.
Right, I guess I was going to say that we haven't met in a while, and this is how it shows.
Ah! I'm almost there now. Is there any way I can? I'm sharing through the browser. I hope it's just large enough.
That works, but
So,
there's probably a full screen button at somewhere.
well, it's not a Chromebook, so.
All right, well,
Oh,
while
wait.
you figure that out, maybe Ted should get started. Ah, there we go.
Okay, you're up, Ted.
Yeah, so
We can't hear you well.
Yeah, you're
You're
very muted. Are you
not
which
muted.
microphone? Well, yeah, actually, yeah,
Soft.
it's just very dim. Yeah, or soft is the right word, I guess.
No, that's worse.
I did nothing.
You're very, very soft.
By the way, do we have a note
Audio.
communicator?
Yes, so Stuart's taking notes.
Okay, thank you, Stuart.
And Ted, if you go into the audio MIDI setup app, maybe you're on the wrong microphone, or maybe just in the Meet Echo settings in the top right.
And you know, I found the weirdest thing in that even though I had selected my audio on Meet Echo, that I actually had to go in my laptop and select the right audio output, that it refused to acknowledge my Meet Echo choice.
Yeah, still, we can't hear you, Ted.
Okay, can you hear me now?
Yes. Maybe just if you could have a little more volume on your microphone, but if not, that's okay.
Let me see if I can do that.
It'll do.
Input. Okay, is this any better? Did that improve anything? Okay, I can, like, how about now? I don't want to go too high or I'm going to start clipping.
No, you're fine. I can hear
Okay.
you. You're very intelligible at this point.
Yeah, this is good.
Let's hope that I'm actually intelligible when I start talking. So I actually have been doing a whole bunch of work that is a combination of HomeNet and DNSSD related work, or at least so I claim. And so, can you guys still hear me? All of the video just died.
Yeah, we hear you.
Okay.
I just,
Okay. Sorry.
we decreased our
So
videos.
I've been working on this sort of project that's involved a bunch of stuff having to do with HomeNet and DNSSD. And so this presentation is actually a combined presentation with all of the stuff that's on the agenda for both working groups in the same presentation because they're deeply interrelated. There's a question in the air as to whether some of this work is HomeNet work or whether it's not, partly because HomeNet has been fairly inactive for a long time, and so it's not clear that there are people in the HomeNet working group that would like to work on this. So that's something we need to explore. But it's certainly topical for HomeNet, and it comes out of the work that I did in HomeNet several years ago. So let's go to the next slide.
Oh, it's not progressing. Let me see. Just a second. I may have to.
Now I'm not hearing Barbara. This is really bad.
Oh, really?
I can hear Barbara.
Yeah, and it's just that I'm pushing buttons for my slides to progress, but they're not. Oh, okay, there we go.
Barbara, I'm seeing you talking, and I see the little thing making noises, but no, and there David spoke, and I didn't hear that either. This is really, really bad.
Well, he's not going to hear me. Let me type in the chat.
Tell him we hear you, Ted. We hear you and we love you. You may proceed.
Let me see what happens by going from a different browser.
So, Barbara, I have a slight problem though. On the IETF webpage, it starts with a DNSSD first, and here we are into the HomeNet part. Some other people will join just for HomeNet and this part, Stub Networking, which is scheduled in 1 hour.
So
I would really, sorry Ted, if you wake up too early, but you were scheduled at 13 UTC in 1 hour for this part. So I would really and strongly suggest that you start this part in 1 hour. Other people are interested in this part, right? So that's your fame, basically. We don't hear you, Baba.
okay, now it's sending audio, really. Okay, so yeah, I was about to discuss that with Ted because we just got the slides, well, rather late for me from Ted.
I think Ted is offering to present, which might make it easier. How about we let him? What do you think, Barbara?
Well, let's get audio. So Ted, are you wanting to do the presenting?
Can you guys hear me now?
Yes.
Yeah, we've been hearing you the whole time. It was for just some reason you couldn't hear us.
I don't know what's going on. Like I'm just having the worst trouble here. I'm hearing you through my computer speakers, not through my headphone speakers for some reason. Anyway.
So Ted, did you want to present or do you want me to, you clicked the present button.
Oh, did I?
Okay, so I'll just keep presenting. Now, Eric was bringing up a question in that the way we put the agenda together was DNSSD topics first, and there's probably some people joining for DNSSD topics first, and we put Stub Networks as the start of the second hour.
Okay.
And I noticed that your DNSSD update slides were kind of embedded in the middle of this presentation.
Yeah, I mean, we could just go over those and then wait until the start time for the next bit.
Okay.
I strongly suggest this because I got at least 2 other people asking me, please ping me when the HomeNet and the Stub Networking starts. That looks like it's an important topic for many people, Ted. So
okay. All right. Well, so yeah, I think if we start here, that gives us the DNSSD stuff. Sorry, I should have looked at the agenda when I was preparing the slides, but I was like, I've just been completely maxed. So can you go back one slide? Yay. Okay. So I was basically trying to weave these two subjects together because they're so tightly interrelated. But since we have this split agenda, let me just talk about the things on here that are DNSSD, which is the first 4 items. So what I've been working on has been, so SRP is actually very mature at this point, and is able to be used by, so the use case that we have right now is IoT devices registering to be able to be discovered. And that's been working. We had an independent implementation that was done recently, and so that's really quite a long ways along, and I think it's actually pretty close to ready for a working group last call, and I'll hit that on another slide. I'm just going to give you the overview here now. So the service registration protocol is about getting information into the DNS database. That's pretty much done at this point. The work that's been going on, that went on last year, was the advertising proxy, getting an advertising proxy which can advertise what's in that database on a link. So the idea is you have, normally we do DNSSD with multicast DNS because it's really easy, it's permissionless, etc. But that doesn't work when you're going across subnet boundaries, and that was one of the issues we ran into when we tried to deploy it in HomeNet. So SRP is a way to do DNSSD advertisements that doesn't rely on multicast DNS. And however, the reality is right now all of our clients are doing multicast DNS, and so we needed a way to, and by the way, there's no way to permissionlessly incorporate a new DNS zone into your network configuration. So we have to use multicast DNS for advertising right now. So the advertising proxy is sort of the other half of the service registration protocol. It's like now that we've got the database, how does somebody find something in the database? And right now we're doing that with multicast DNS. So that's the advertising proxy. Stuart did a version of that document, and it's pretty complete, but it's not sufficiently detailed, so that needs a fair amount of work. And then additional work that's been going on this year is, so SRP was originally envisioned as something for updating stateful DNS servers. And the idea is a stateful DNS server has, it's on some kind of reasonably sizable computer. There's a disk drive or some kind of flash memory to store information. And so you just do the DNS update, and then you can do DNS lookups to that server. Problem is, in reality, when you go to try and deploy this, there aren't any DNS servers like that in homes. And so in order to make this work in homes, we need something that's hopefully equivalently stable to a stateful DNS server, but doesn't require that there be support on the home router. And so the way that we did that is, the idea is that you probably have multiple stub routers in your home that, the example that I would use right now would be a HomePod Mini, right? So the HomePod Mini is a stub router for thread networks. So you have multiple stub routers in your home. It's possible at any given time that one of those stub routers might get unplugged or whatever, but hopefully at any given time, at least one of them will be alive. So all of the service registrations that occur can be maintained by doing replication so that all of the stub routers in your home network are sharing the information that they're getting from SRP registrations. Any one of the stub routers goes down, the other stub routers take over for it, seamlessly. So that's the goal of replication, is for all of the stub routers, or doesn't have to be stub routers, but that's the use case we have right now, for all the stub routers in a home network to have the same data, so that if any one stub router goes away, we don't lose everything. And then the next issue that I want to talk about is the problem of doing too much multicast. So suppose you've got like an IoT network with, say, 50 light bulbs on it, and obviously it's not all going to be light bulbs, but just as an example, 50 light bulbs. Now, when you try to use an advertising proxy to advertise those 50 light bulbs, you may find that your performance isn't that great, because advertising proxies are using multicast, and now we've got big chunks of data that we're trying to transfer over multicast. And also, multicast DNS really wasn't designed with the idea in mind of having a single server with 50 answers. And so in order to work around that, I've been working, actually one of my colleagues have been working on a feature to add the ability to discover an actual DNS server using MDNS. So those are the 4 pieces that I wanted to talk about. So let's go to the next slide. Okay, so yeah, so this is that problem. When you have a lot of devices behind a stub router, the answers get really big. It's not scalable. Can we use multicast more efficiently? So rather than using multicast to transfer all of the data, can we just use multicast to discover the place where the data is, and then use unicast to get the data? So what we implemented was exactly that. We basically just advertise an NS record for whatever zone it is on the local network using multicast DNS, and we exclude actual real DNS domains so that we don't find ourselves answering questions about bankofamerica.com or something bad like that. And then once we get that NS record advertisement over multicast DNS, we can get the A record also over multicast DNS, or the quad A record, and now we have a connection to a DNS server that will answer for that zone. So this is something that we've been working on for a while this year. We have one implementation. It's in the MDNS Responder project. That's not actually been pushed out yet, but it'll be pushed out soon. And we have actually a fairly good document, but I haven't gotten around to turning it into an internet draft. It's actually just an internal design doc that needs to be turned into an internet draft. So this is work that I'd like the DNSSD working group to consider. I think this is a really useful thing to be able to do. It'd be nice to have more eyes on it. I think it's relatively harmless in the sense that we're essentially advertising only zones that only information that you would typically be discovering with multicast DNS. So the fact that we're, advertising the availability of a DNS server using multicast DNS, which is not in any way secure, might sound a little alarming, but the actual thing that we're doing is just replacing existing multicast DNS servers with that DNS server. So let's go to the next slide. Okay, so service registration protocol, as I mentioned earlier, we've got 2 open source implementations. I did an implementation about 2 years ago, which matured into what was released in the HomePod Mini. And then independently, some folks at Google did a very nice implementation, OpenThread, which is pretty complete at this point. And if you were following the mailing list, you saw the comments that those guys had on the document. And so we've made quite a few improvements to the document. The document's had tons of review. We've actually got deployed versions of this protocol. So server in the HomePod Mini, and there were a bunch of HomeKit accessories that implemented, like Eve sensors and nanoleaf light bulbs. I think this document is pretty close to ready for working group last call. It probably needs one more revision, but I think if the working group is willing, I'd really like to see this finished. So that's it on SRP. Next slide. By the way, if anybody wants to chime in and argue about this, I'd be more than happy to argue about it. So again,
we'll
I just
open up the queue for argument when you're, yeah, we'll open up the queue for argument. Don't worry.
Okay, cool. So so I mentioned the advertising proxy already. Stateless. It's a stateless SRP registration database that advertises its contents over MDNS or DNSSD. We have an implementation of MDNS Responder. I think the OpenThread guys did one too, but I'm not sure where that is in terms of maturity. The advertising proxy spec needs a bunch of work. Definitely would appreciate people reading it, and I'd also like to ask the working group to consider adopting it. Next slide. Okay, and then SRP replication. I pretty much already gave you the spiel on this. My implementation is a state machine that 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 runs through the SRP database on the local server and proposes updates to the remote server. The remote server does the same thing. After all of those updates have been done, in principle, you're in sync. It's possible that there might be conflicts because if the two servers had been operating independently, one of them might have received an update that's incompatible with an update that the other one received. And in that case, there needs to be some kind of conflict resolution. But we also try to do conflict avoidance. So when an update comes in, we attempt to update the other server before we acknowledge the update. So if the other server has a conflict, we can report the conflict back to the client and resolve it that way. Obviously, we can't wait forever for that, but this gives us the nice quality that most of the time we can expect things to work correctly. Occasionally, we'll see some glitches, but they should resolve quickly, within the least time of an SRP update. So the goal here is not perfection. The goal is to make something that works really well, and that when it fails in a way that ultimately produces a good result. That is to say, the failure gets sort of automatically cleaned up. So the experience you would have on this is basically just that you're going to see, hopefully right now with the existing SRP implementations, you're not seeing a whole lot of instability with name registrations, but this will make the name registrations a whole bunch more stable. So you get better reliability, better user experience. I haven't described this thing to anyone else, so as far as I know, it would be kind of surprising if anybody else has done an implementation. I need to write a document. I have an outline of a document, but I haven't written the document yet that just describes what the protocol does. I think the protocol probably needs a whole bunch of eyes on it. I think it would be good to get some criticism of it. After having done the implementation, I already had some ideas for what I would do differently, and it's not cast in concrete at this point, so it'd be great to get some working group eyes on that. So that's my next thing. And the next slide. Okay, I think, let me just go through my copy of the slides and make sure that there aren't any other slides we should be talking about. No, that's it. So I guess at this point, this would be the time to discuss these slides and whether the working group's interested in this work.
Okay, so as you said, oh yeah, I got audio. There was a whole lot of discussion on, I guess it was the SRP draft. Mm-hmm. And I'd like to open up the microphone for anybody who has further comments or who would like to voice their support. Ted has asked that this go to working group last call, so if you have technical comments or questions on the SRP replication, or if you have administrative comments, like we would love to see this go to last call and we think it's ready, that would be welcome. Since Ted is here, the mic is also open for the other drafts. There's the draft you'd like to suggest that we adopt. And then I think, just technical comments on the SRP replication, because that's not ready for adoption or anything. So my line is open. This could be Esco, please.
Yeah, hello. I was just wondering, for SRP replication, was there already a published draft for that?
No, that's basically work that I have just been working on. It's the reason why these slides are so
okay.
Why these slides were so late. So yeah, that I have an outline of a document that describes the current implementation, and I should be able to get that ready within the next month. So so that's the level of maturity right now, which is to say not much.
Okay, so that's coming up, yeah. And then for SRP, I had one thing in mind. You mentioned that before the working group last call could be done, you wanted to have probably one more revision, right?
Yeah.
And I think that at least fits well in my schedule, because I would like to check the latest version to see if the review comments I had were addressed. So I didn't get around to that yet.
Okay.
Maybe I can do that just before the next revision.
Yeah, I'd like to get that one revised quickly and get it to last call quickly. We've done a whole bunch of work on it. It's in people's cache right now. I don't want it to fall out of everybody's cache. So basically, and speaking of falling out of cache, I think there are a few more edits I need to make to the document based on the most recent comments about deletion of SRP updates. But I haven't, I'm not positive. I know that the document has a bunch of text about that already. And so it may be that I've already done all of those, in which case there isn't a whole lot more for me to do. But let me just do a pass through my mailbox and make sure of that before, and you know, if that's the case, I'll do a rev, and then you can look at that document and review that document. And you know, working group last call doesn't mean we're done. Working group last call is please review this document one more time. So it would be perfectly fine if you reviewed it at that point.
Okay, that's fine too.
Thanks. I really appreciate your comments, by the way.
Thanks. So Ted, we're gonna wait on you publishing one more revision before we start the working group last call.
All right. Sounds good.
And for the other documents, before we even start talking about adoption, we would like to know that the document exists. So, yes. You know.
Yeah, so there is an advertising proxy document.
So advertising proxy exists, and that was the one you were asking about adoption.
Yeah.
The other one is the work in progress that is still a gleam in Ted's eye.
Right. Yeah, I'm not asking the working group to adopt those documents sight unseen. You're not. I just kind of wanted to give you guys a heads up.
Yep. Eric, you have something you'd like to say?
Yes, thank you. So more about this SRP replication. I understand it's still not in the air completely because there are code existing. Can you shed some lights on it? Are you using DNS replication, like zone transfer between zones, or do they discover each other?
Yeah, so yeah, I can talk about that a bit. It's actually implemented using DNS stateful operations. I thought about using zone transfers for this, but the problem is zone transfers, the way that zone transfers work is that they rely on an agreed upon serial number for the zone. And so basically that makes zone transfers work really well, because when somebody says, you know, I have this serial number, can you give me everything that's changed since this serial number? You just get this small change set and it's really clean. But that doesn't work so well with stateless servers, because there's no way to, we don't have like a primary server and secondaries. Everybody is in principle just as primary as everybody else, or just as secondary as everybody else. And so using zone transfers just didn't look like it was going to work. That's how I wanted to do it, but it just didn't make sense. So there are a couple of assumptions in the protocol, and these may actually be bad assumptions that would be worth investigating. One of them is that there's probably not a gigantic database, because if you have a gigantic database, you probably want that to be in a real DNS server. So this is really more for the sort of, you know, home environment where you might have 50 or 100 things in the database, not thousands or tens of thousands or millions of things in the database. And so making the protocol efficient in the way that incremental zone transfers are isn't as high a priority, because you could get into a situation where you have you know, kind of an n, probably not n squared, but maybe n log n kind of traversal across the database. And if that was going to be millions of records, you really wouldn't want to do that. But that's not the case here. So the way that it works is really stupid, and that's sort of by design, right? I'm not trying to do like a super fancy, you know, state synchronization protocol with 3-phase commits and stuff like that. But basically to just do a, you know, let me see what you have, here's what I have, and let's, you know, I'll take the new things that I haven't heard of from you, and you know, all of the sort of the things that you would be concerned about, like, you know, what happens if I get a DNS update, or an update from a server just as an update is coming in from a client that's for the same record, and you know, how do I avoid, like, when I get an update from the server, not seeing that as the same thing that I have to send back to the other server and getting into a loop that way. So there's all kinds of stuff like that. But the basic replication protocol is its own thing. And as I said, it's really stupid. It's pretty easy to implement. My state machine is on the order of maybe 1,500 lines of code. So, and actually I'm kind of suspecting that it could be made simpler. And that's the direction that I would tend to want to go. If we have to go in the direction of remembering states so that we can do incremental transfers based on differences between states, I think that's a whole different topic. Possibly an interesting topic because we haven't really solved that problem for DNS as a whole yet. That's not really the problem I want to work on in this, unless we discover that we really have to work on it. I'd much rather work on a simpler problem.
Okay, so for the SRP, we're going to wait for another update, and then we'll start a WGLC on that. Mm-hmm. We'll send an email out to people asking them to comment on the advertising proxy, just to gauge, I think, some interest in it. And if there's interest, then we can put out a call for adoption. But I'd like to at least see some discussion on it, I think. David, what are your thoughts?
Definitely agree. I don't think there's been enough discussion for us to start adoption right now. So let's see, Ted, if you can maybe drum up some interest on the list, and with that, we can move to an adoption call.
Sounds good.
And we'll wait for a draft. Looking forward to a draft on SRP. Is it duplication?
Replication. Replicates.
Replication. Okay. And I think then that really is a summary of all of the work we have going on in DNSSD. Do we want, we had said that HomeNet would start at the top of the next hour. Do we want to take a 5-minute break while we send out an email to the HomeNet list that we're going to be starting at, let's say, at 45 past the hour with HomeNet, and then start then?
Yeah. It might be that, so Daniel Migo's draft for HomeNet is actually very relevant to DNSSD, so it might be good to start with his, because if there are any stragglers that are just interested in the routing stuff, they'll probably, I suspect the DNS people are already here.
Well, and they can stay here. Your Stub Network was actually pretty interesting, so I think we'll just proceed with our regular plan. But I'll send out an email to the HomeNet list that will start at 45 minutes past the hour. We'll take a small break and reconvene at 45 past the hour and get going on HomeNet. And Stephen, is that okay with you too?
Pretty much, yeah. I think I like Ted's suggestion maybe to look to maybe flip the HomeNet agenda so that Ted's slot, which is the kind of new thing that might attract people, it does actually start around the top of the hour. So if we do Daniel and Michael first, that might make more sense. Eric, does that kind of chime with the interest you had in this topic?
Yep.
Okay, so start at 45 with, let's say, Michael and Daniel, assuming they're available.
We'll start at 45 with the formal agenda bashing, in which case we'll have that proposal and then we'll get started. Okay.
More coffee, though. More coffee.
More coffee. Okay. At 45, let's see. I'm going to escape these. I'm sure I can do this. Okay, and y'all are all free to come back at 45, and I'll send an email first.
So Barbara, if at some stage you want me to present, then I can do that. If you rather do it, that's fine too.
So I've got these things up, and I think I can show them. Let me see.
And I guess, Stuart, are you willing to keep on helping with minutes?
We'll continue doing that.
So say again?
I said, yes, I will continue taking notes. I have not used this CodeMD tool before. Are the edits I'm doing now, are they showing up visibly to everybody else?
Yeah, it looks good to me. Yep.
Okay.
And so just keeping on at the same file or page or whatever is just fine. We can grab the text from. Thanks a million.
Yep.
So thanks. Let's go ahead then and get started. HomeNet session, we're session 1, not 2, but other than that, I think I got things mostly accurate. Again, we are still under the note well, which was already shown at the start of the DNSSD, but here it is again, note it well. And the agenda, this was the overarching agenda for the 2 sessions. We did go ahead and have Ted Lemon talk about the, let's see. Oh no, this is just the HomeNet agenda, right. So the HomeNet agenda, we had initially put Ted on first, but Ted and others have suggested that if Daniel and Michael are open to starting, that it would probably be useful if they went first on the aspects of the delegating names. So Daniel, would it be okay with you if we swapped the order and you went first?
Oh yeah, no problem at all.
Okay, then that's what we're going to do, and we'll have the wrap up at the end. We did go ahead, Stuart is going to continue with notes. Just a quick comment on some document status items. The Babel profile is not yet published. It is still waiting specifically for the Babel item on the, oh, what was the name of that? It's just so early.
The source address now.
Source, right, source specific, which I think Julius said that his current intention is actually that technically it's correct, he said, but it's very poorly written in his opinion, and so he intends to rewrite it, and he'd like then for it to go all the way back through WGLC and IETF LC and all of that. So that one may be a while. With that, I'm going to then bring up Daniel's slides. Let me see.
Hi, everyone.
Yeah.
Yep. So I think I'm going to be very brief with the 2 draft on that. So we're 3-person very actively working on those and regularly chatting on it. We try to report what we're doing on the mailing list as well. But here it is. Next slide. So just a quick reminder about what we're doing. So we're basically defining how a HomeNet can outsource the DNS service to another infrastructure. And we designate this infrastructure the DNS outsourcing infrastructure. And the entity within the HomeNet that is orchestrating this outsourcing infrastructure is called the Home Naming Authority, which is designated HNA. So in a HomeNet, there are basically 2 kind of zones. The forward zone, which here I represented with HomeNet.example, and you also have the reverse zone, which is here IP.IPv6 .arpa. So in this environment, the ISP has a specific position, mostly because for the reverse zone, the ISP is providing the IP address and is also responsible for the reverse zone. And in most cases, ISP already assigns a name to CPEs, for example. So the ISP is likely to play a significant role in that. So given that, next slide. So we ended up in 2 drafts. Well, ended up a long time ago. But the first one is really describing the architecture and how an HomeNet can outsource its home zone, DNS zone, reverse or forward, to a DNS outsourcing infrastructure. There is no assumption about who is that DNS outsourcing infrastructure. It could be a third party. That's the party we took, but it could be the ISP as well. And then, because in this kind of environment, the ISP has a special role, we defined a second draft, which helps and ease how an ISP can ease the configuration of the HomeNet naming authority using DHCP. And so this is why we have this naming architecture DHC options. So it's clearly only intended to help the communications between an ISP and a CPE that is using a DHCP. Next slide. So so for the front end, I mean, the document is, relatively stable now. We're working on an implementation, and currently, I'm saying it's Michael because he's not here, probably. So he has the ball. He's polishing his implementation, and we will take the feedbacks from the implementation to the draft, so that we can check everything works as we expect. For the DHCP options, we had some discussions on the mailing list, and we recently changed the design. So the change we made is that for the previous years, the HANA was supposed to provide the key that's going to be used to be authenticated, to authenticate the HANA from the DNS outsourcing infrastructure. So basically, the previous scheme was the HANA is providing the credentials via DHCP that are going to be used and transmitted to the DOE, and so that the DOE can authenticate the HANA. It has been shown that such way of working is, I could say, insecure, or at least does not really make any operation sense, because DHCP can provide some response that are adapted to a specific client, but DHCP is not being used to upload some configurations from the network to the core network, in which case, in this case, the DNS outsourcing infrastructure could be seen as the core network or upstream network. So what we ended up with, we removed this option public key from the current specification. So we believe that, the intent is that the ISP, when he's using DHCP, he knows who he's talking to. He's able to authenticate he knows which line, which client customer is on the other side of the wire. And so there is no need to provide this public key from the HANA. Next slide. I think that's all, but I just want to make sure. Yeah, so this is what I just explained. Yeah, so this is where we are. I don't want to say that we're going to be done by next IETF, but we're slowly moving toward that final stage.
And so right now, you have the only implementation, is that right?
So no, the only implementation is from Ray Hunter.
Okay, and so it would be nice if we did also have additional implementations, and I think that applies to Ted's draft as well, that it would be nice if we got additional people trying to implement Ted's efforts in DNSSD. And so you think maybe another revision, and then you'd like to try for a working group last call. And we're going to have an overarching discussion about, I guess, things in HomeNet and trying to make sure we get enough review and support at the end of this session. And so we'll hold off that discussion till then. Does anyone, the queue is open. Does anyone have questions or comments for Daniel? Okay, so we'll have that discussion about where this work should live in order to make sure it gets sufficient review after we hear from Ted, if no one has any questions or comments for Daniel. Okay, then if it's okay, I will bring up Ted's again.
So, Barbara, jumping in a bit late, Daniel, I have a question for Daniel, actually. You said there's an implementation. Is that available? And if so, could you just send a mail to the list or something with the pointer?
Yeah, I mean, it's available somewhere, but I can't. I don't really know where.
Yeah, that's okay. I mail to the list here tomorrow is fine.
Okay. Okay, right.
Great, thank you.
Okay, should I get started?
Yeah.
All right. So I'm going to talk about the sort of the whole Stub Networks problem.
Are you hearing me?
Yeah.
Hi.
Go ahead, Stuart.
Just before Ted starts, I wanted to take this opportunity to thank Ted for his amazing work on this. 18 months ago, Apple asked us to look into doing HomeKit over Thread. And what we found was that the big gap in Thread is they didn't have a border router, the equivalent of a Wi-Fi access point, the thing that connects your Thread network to your home network. And just bridging that, like the way you do with Wi-Fi, would overwhelm the slow Thread network. So Ted's work on SRP plus the Stub v6 networks is what made that possible. And Ted, in addition to working on documents, did amazing work in 1 year writing the code to go from concept to shipping product. So that was pretty incredible. We shipped HomePod Mini last November. There's already a bunch of third-party HomeKit accessories running over Thread using SRP and the Stub Networks work. Of course, we don't want it just to be the HomePod Mini. We don't want to see a whole market full of other third-party border routers, and that's why standardizing this work is really important. But I wanted to thank Ted for his amazing work over the last 12 months getting that shipped.
Yeah, that's why I have rings under my eyes and late slides. Anyway, so what I want to talk about is exactly what Stuart just described, sort of the permissionless adding of stub networks to existing network infrastructure in order to deliver reachability and discoverability to the devices that are on the stub network. and from the devices that are on the stub network. So, so just to clarify what a stub network is, it's a leaf node. There's no through traffic. Stub network is not a transit network in any sense. It connects to an adjacent network, and there needs to be some way to get packets between the two networks, both directions, obviously, and it needs to be possible to discover devices on the stub network from the adjacent network, and ideally from the adjacent network, discover devices on the adjacent network from the stub network. So essentially the idea here, considering the use case that Stuart just described, the idea is that in the case of HomePod Mini, it'd probably be a HomeKit accessory, right? My HomeKit accessory that's connected to the stub network through the HomePod Mini has the same user experience, the same discoverability, the same reachability as an equivalent device that was connected directly to the Wi-Fi. That was our goal. So that's like the minimal required functionality, gets us basically what we need. And then additional functionality, some devices need to be able to reach out to the cloud, maybe for firmware updates, maybe because it's like a cloud-based IoT service, not a home-based IoT service. So reachability to the cloud, and when I say reachability to the cloud, I'm talking about the equivalent functionality that you have now in a NATed home network, where devices that are sitting on your home network are not reachable from the cloud. You can't, like some server out in the cloud is not going to be able to make a TCP connection to a device on your home network, but the device on the home network can make a TCP connection out to a device on the cloud. And so that's what I mean by reachability to the cloud. Full routing would be, there's two aspects to full routing. So you've got adjacent, now an adjacent network would be just like a link that the stub network is directly connected to. The stub router is directly connected to that link. You could also have non-adjacent networks that are reachable, and that's what full routing is about. So that means reachability. Suppose you've got a subnetted home network, or this is a small office network, or maybe a commercial building network, and you want to be able to discover and reach devices on the stub network from anywhere on the multiple subnet LAN, and vice versa. That would be full routing. And then in order for that to really work well, then you need probably some DNS infrastructure that's being updated rather than the advertising proxy stuff that I discussed earlier. We'll be going over the stuff I discussed earlier in case there are latecomers who didn't hear that. So that's the goal, is basically, first of all, minimal functionality, just the equivalent of what's available now, only with your devices that are one hop away. And then ideally, full mesh routing and all of the sort of things that you would expect from a home net. And in fact, it's because the minimal functionality is a building block in the direction of the functionality that we wanted for HomeNet that I think this is relevant to HomeNet. I think this is actually like the problem. Well, I'll talk about it in a little bit. Let's go to the next slide. Getting ahead of myself. So how we got here, so we started out trying to do everything, right? We wanted the full mesh topology we wanted to automatically discover the entire home network mesh. We wanted full mesh routing, we wanted full mesh naming. That was a really hard problem. Even figuring out how we wanted the naming architecture to look was hard, because some people wanted one thing and some people wanted another, and we had lots of discussions about that and never really came to consensus. HNCP was published, but it never, Stuart was talking about the work that it takes to get a product to market. Getting the spec to the point where you think it'll work is a very different thing than getting the product to market and actually having it be usable by people. And we never got there with HNCP. HNCP was originally motivated by ISPs who wanted full mesh routing in the home, and so, but the problem was that it took too long, and there wasn't momentum in the home router community, and so that enthusiasm on the ISP side never translated into implementations on the home router side. And so basically we did all of this work, and we didn't, at least thus far, we haven't gotten anything out of it. And so, the Babel work has been proceeding, and that's been really cool. I have high hopes for that work. Actually, I'd like it if that work could become part of the stuff that we've been doing with Stub Networks. I think that that would make Stub Networks a lot more useful, because right now, suppose you have two Stub Networks connected to the same adjacent infrastructure. You have reachability to both of those Stub Networks. You have discoverability on both of those Stub Networks. But suppose a device on Stub Network A wants to configure a device on Stub Network B. How do you do that? You have to have routing in that direction too. And you know, we can sort of do that with router advertisements, but it'd be way better to have a real routing protocol. So anyway, the point I'm getting to here is that I think we actually, by starting with the top-down approach, we kind of ran into the best is the enemy of good enough fallacy, and that's how we got here. So next slide. So basically, where we've been going recently, and you know, talk a little bit about how this started. Stuart and I were at a thread meeting in Munich a couple of years ago. Actually, I think it was a year and a half ago, maybe 2 years ago, and we were talking about, like, how do we get this stuff into homes? How do we actually deploy multiple subnet home networks? Because we have to have multiple subnet home networks for IoT. I mean, it was a nice idea for like general purpose, but for IoT, it's absolutely required. How do we get this into homes? And so, how do we, in a permissionless way, deploy it in existing infrastructure? And so that's where we came up with the requirements that I described earlier. We have to have equivalent functionality to devices on a home network, and it needs to support existing use patterns. If something worked for a device that was connected directly to your home network, it should work if it's connected to your IoT network. Just to be clear, I'm not saying that stub routers are just for IoT. It's just that that's the use case that we exploited to come up with a solution. So next slide. So what we have now, there are two stub network implementations. The HomePod Mini has a complete implementation of the basic functionality that I described earlier. And OpenThread at this point, I don't know if it's merged into OpenThread yet, but we have a really nice implementation of the SRP stuff in OpenThread. You know, I think that at this point, the OpenThread guys also have routing working. So those are the two bits of a stub network, you know, routing and discoverability. So these are independent implementations. I didn't actually talk to the guys other than basically the conversations that we had on the mailing list. So this was on the DNSSD mailing list. So if any of you were on the DNSSD mailing list, you probably saw those conversations. So we have these two implementations. They are not full implementations. They didn't do everything. They're evolving, but they deliver the functionality we need. We can control accessories that are connected to the stub network. We can discover accessories that are connected to the stub network, and so on. Next slide. So this is a little bit of a wish here. This is like where I would like to see this go. I'm not convinced this is where it's going to go, but I'm mentioning this because I think that if this is of interest to HomeNet, this is probably a direction that we might want to consider going. And that is, can we scale up this stub network solution? Can we use this as a building block to actually get to the point where we have a complete HomeNet solution and not just stub networks? So in order to do that, we need to add Babel. We probably want to have SRP on the edge router. And we need some way to get prefixes to internal routers. That could be DHCP-v6. It could be HNCP. Problem with using DHCP-v6 is that DHCP-v6 binds an ID and a specific IP address to a delegated prefix, and there isn't actually a way to set up routing. So Babel might solve that problem. If we can advertise routes in Babel, maybe we don't need to solve the problem of how routing is set up, but we still have the problem that only one thing can own a prefix. And that was a problem that HNCP tried to solve, and I think to some degree did solve. I don't think it's a perfect solution. So one way to go forward with that would be to actually revive HNCP and try to make it into something that's actually realistically deployable. But these are things that I think are topics that would be worth discussing. Next slide. So, and to get a little bit more into that, right now, like I talked a little bit about the CE routers, customer edge routers, basically don't have any incentive to implement HNCP or any of the other HomeNet stuff. Because most of the time they're going to do all of this work to get into the router, and then you're going to plug the router into your network. There are going to be no stub networks connected to it, right? There are going to be no other routers in the network. And by the way, if they made it really work well, it would actually cut into their mesh sales, right? So they actually have a bit of a disincentive. Plus, mesh actually gives a better UX. I talked about this a lot of HomeNet meetings ago, that like, you know, and actually I had this experience the other day. I was thinking about the talk I gave at IETF a while back, you know, I was on a voice call on a meeting. I had my iPhone in my pocket. I was using my earbuds. This was over IP. And I needed to go do something in the garage. And right now I have mesh networking set up at my house. So basically I was listening to the meeting on my headphones, walking out the door, outside of the Faraday cage. The connection dropped for a minute, but then it recovered, and it was connected to my to the mesh router in my garage. So so that's like a really nice UX, and so there's a reason why router vendors didn't want to do the HomeNet subnetting model for that particular use case, because if that had happened, then I would have had to entirely reestablish my connection. It wouldn't have just been like, oh, I missed some TCP ACKs. I need to wait to catch up with that, and then everything will be back to normal. It would have been, I need to tear down the entire connection and reestablish the entire connection. Of course, we talked about NPTCP and other technologies for addressing these issues, but the bottom line is, right now, the UX is way better on mesh than it would be with a subnetted home network. So, so that's not going to motivate router vendors to put this functionality in. If, however, there were already devices in the home that could take advantage of this functionality, then when a CE router vendor puts this into their router, they have differentiation. They can say, your network is going to work better because you bought our router. And so to me, that seems like a better model for trying to get widespread implementation of this stuff than the model that we started with, which was the router vendors should do it, and then everybody else will follow. This way, we're basically giving them an incentive to follow, and we're not taking anything away from them, because the use case that they're addressing right now is, how do I get my IoT devices to work better? And you know, by the way, if I buy another router and plug it into the network, you know, it would be nice if like I had bidirectional connectivity. So anyway, that's kind of my pitch for why this is a HomeNet related topic. Next slide. So the building blocks we have right now, and now we're back into the stuff that I presented earlier. So if you were in that presentation, there's going to be a bit of review here. We have a bunch of naming stuff. We have a way to register names. We have a way to advertise those names using multicast DNS. We have a way to create a reliable name database using devices like I've been talking about, stub network devices that are just like, you know, a HomePod Mini. I mean, your HomePod, you don't think of your HomePod Mini as a server, right? So it's perfectly fine to power cycle it or, you know, install a new software update on it. There's nothing wrong with doing that. It's not going to break your network. However, if it's got all of your SRP registrations in it, you're going to lose all those registrations and you're going to have to somehow regenerate them. Because of the way that SRP works with conflict detection, if you lose all of your information, you could wind up getting surprising conflicts when you recover. It's not a huge problem, but it is a problem. So being able to have a stable store of name information, service discovery information, will create a better user experience. And so that's the replication piece. And then the ability to discover browsing zones so that you don't have to use multicast DNS for every query. If you know, normally like in a typical home network prior to sort of, you know, everybody getting light bulbs that had Wi-Fi in them, there might be like 5 or 10 services on your home network. So there was a certain amount of multicast traffic, but it wasn't like a huge amount of multicast traffic. Now we're talking about like a lot of devices advertising their services, and they're being advertised by the SRP advertising proxy And so all of those answers are coming in multicast packets, and we're starting to get into situations where they might overflow and might wind up with a lot of packets. And so, is there a way to use? Is there a way to get as much of that traffic into unicast traffic as possible? So, and then the fifth item on the agenda here is the actual Stub Networks document. So this is the I want to build a stub network. I want to have a stub network. What do I need to do to get the stub network working? What do I need to do in terms of addressability, reachability, discoverability, and so on? So those are the topics. So let's go on to the next slide. Okay, so I mentioned discovery browsing zones. The deal here is that it would be really nice to not have to do all of our service discovery with multicast. And so the one way to do that is to add a level of indirection. Basically, I would like to discover the server that I'm going to get my information from using multicast, and then do all the rest of my discovery using unicast traffic. So the idea here is that we'll advertise an NS record using multicast DNS. We'll advertise an A record or a quad A record, or more than one that answer the questions in the NS record, and that gets us to a DNS server that we talk to using multicast. Oh, sorry, unicast. So, and in order to avoid like spoofing, we only allow home.arpa. We might allow service.arpa as well. That's an SRP zone that would be registered when SRP gets published. So this is a solution to the problem of too much multicast traffic on your network. I'll talk a little bit about the problems with that later, but because there are some issues that are actually kind of more HomeNet specific than they are DNSSD specific about how to reduce multicast traffic. So we have a draft on this. We haven't published it yet. A draft of a draft, I should say. It's not in an internet draft form yet. And that's going to be worked on in DNSSD. But I mention it here because it's relevant to the, it's a service that you would expect to exist on a stub router. Next slide. Okay, similarly, service registration protocol. This is a unicast protocol for doing DNSSD advertisements. And again, it's a service that needs to be available on a stub router in order for discoverability to work. So if you want to be able to discover stuff on the stub network from the adjacent infrastructure network, which would be typically your home Wi-Fi or your home Ethernet, you need a way for the devices on the stub network to register their services with the stub router, so the stub router can advertise them on the home link. So that's SRP. SRP is it's got this thing called first come first served naming, which allows you to claim a name using a cryptographically secure authentication mechanism, and then you get to keep that name until it expires. And so this is something that's already been implemented. It's on the HomePod Mini. There are a whole bunch of thread accessories that support it, and that's something that's actually quite mature at this point, and we're hoping that the working group will go to last call soon, but that's the DNSSD working group. So that's pretty mature. Next slide. Advertising proxy, I talked about this earlier. Basically, the idea is you have this database that you've built up with SRP. Now you need to make it available to devices that are on the adjacent infrastructure network. The advertising proxy is how you do that. It just basically advertises everything that's in the database that's being maintained using SRP, using multicast DNS, or using DNSSD. So what I was talking about earlier with discovering DNSSD zones using multicast DNS, now we're discovering the advertising proxy using multicast DNS, but then all of the rest of the queries that we do to the advertising proxy go over unicast, and so that saves a whole bunch of multicast traffic. So that's another thing it's we've got several implementations of that, and it's in pretty good shape, but we still have work to do in the DNSSD working group. This is something that's going to be part of the stub router specification. Next slide. SRP replication, I mentioned this earlier. You need to be able to have a stable database, or you'd like to be able to have a stable database of SRP clients and not lose them when there's a reboot. So that's SRP replication addresses that issue. I won't go into great detail about SRP replication here unless somebody wants to ask more questions. Next slide. Okay, so now the Stub Networks document. So this is the document that's actually the core work that I wanted to talk about for HomeNet. There are actually two documents. One of them is a problem statement. It basically says, you know, here's the problem we're trying to solve, and here are some ideas that we considered for how to solve it. And I don't know if that document needs to become a working group document. I think it's useful information. Michael had the idea of actually just taking that information and putting it into appendices in the implementation document. So that's another way to go. The implementation document, currently draft lemon Stub Networks, describes how to connect Stub Networks to existing infrastructure. And that document is based on the work that we did on the HomePod Mini and on OpenThread. And it's a pretty good document. It still needs some work. It needs, like, it'd be nice to talk about, people have asked about a state machine for how things are managed. I'll talk a little bit about what's in the document after I've sort of gone over my spiel about maturity. It's not ready to implement. I think it's work that would be interesting to do in HomeNet. And so my goal is to see if HomeNet is interested in adopting it and working on it. And you know, the big question mark is, are there people here who are actually interested in doing this work? And is this a place where they would be willing to do it? It feels a little funny to do this work in IoT ops because I really don't think this is IoT specific. I actually think this is very core to the work that HomeNet was trying to do. And so I'd like to see it done here if it's possible. Another place it could be done is V6 ops. The current document is claiming to be a BCP. You know, obviously if it gets published. And so that would be something that could be done in V6 ops. The problem is V6 ops, that would be very unfocused, whereas this use case is very specific to home networks. So really the question is there interest? I mean, I think the question is there interest in working on this in the home networking group? So I'll talk a little bit about, hang on, let me see. I'm going to look at my own copy of the slides. Yeah, so let me just talk a little bit about what the Stub Networks document describes. So basically the idea is you connect a stub network, a stub router to the adjacent infrastructure network. The stub router looks on the network to see if there's IPv6 service. So one thing to say about this is that currently there isn't an easy way to do bidirectional permissionless IPv4. But it's actually pretty easy to do bidirectional permissionless IPv6. And so we just said, that's what we're doing. We're not doing IPv4 for bidirectional connectivity. You know, it'd be no problem to have an IPv4 NAT behind another IPv4 NAT, and devices on the stub network could connect out to devices that are on the home network or out to the cloud. But we didn't really want that answer because that doesn't give us the ability to operate devices on the stub network from the home network. So hence IPv6 only, all right? So how do we make that work? The stub network router, the stub router looks on the home network and checks to see if there is IPv6 service already available in the home network. That would be a router advertisement that contains a prefix information option that is on link and is eligible for auto configuration or has DHCP-v6 support. Those are the two options. Sorry, I've been talking a long time. My throat's getting dry. I should have brought some water. So, so is there IPv6 addressing already available on the home network? If not, then the home router will advertise a prefix. And this would be a little dangerous, right? Because what if IPv6 service comes back? We don't want to steal the default route from the customer edge router. That would be really bad. So the way we advertise this is using an RA with the default, with the router's default lifetime, sorry, the router lifetime set to 0. So that means don't use this as a default router. And so devices that support that functionality will ignore the RA in terms of setting up their default route. And in fact, this is, you know, we haven't had any issues with devices that don't understand this. The issue that we have seen is that there are some devices that when they see a router lifetime of 0, they just ignore the RA. But that's less of a problem now than it was 2 years ago through efforts that we've undertaken. So so that's how we get IPv6 addresses onto the home network. And we can do roughly the same thing for the stub network. For thread, it turns out that there's a different way of configuring prefixes. We don't use RAs, but basically the principle is the same. You advertise the prefix on the stub network, and and by the way, the prefix that's being advertised here in sort of the normal case is just a ULA. The router creates a ULA and advertises it on the home network and on the stub network, different /64s out of that /48 ULA. And now we have IPv6 addressing on both sides. So that means that nodes that are on the home network have IPv6 addresses, nodes that are on the stub network have IPv6 addresses, and so therefore, in principle, they could talk to each other because they have addresses. The next step is, how do we tell devices on the home network that they can reach devices on the stub network? And that's by, again, doing an RA with the route information option. So RAs have, this is something that was added after the original RA document, that provides the ability to advertise specific routes in the RA. And so we just advertise a specific route to the prefix that's on the stub network, and we're done. Now a host that's on the home network can send packets to the stub network. So then the next step is that the devices on the stub network need to be able to send packets to the home network. And that's actually sort of easy. I mean, one way to do that is to just have any stub router advertise a default route. That works great, except what if you have two stub routers that are connected to different adjacent infrastructure links, but are connected to the same stub network link? Then you have a problem. Because if both of them are advertising default route, then you're only going to have reachability to whichever one is closest to the accessory. Reachability to the adjacent network of the stub router that's closest to whichever accessory is trying to talk to that device. So if we want to support that use case, and I think we do, then we actually need to advertise essentially the same thing on the stub network side. We need to, if the stub network is a Wi-Fi network, then we would advertise route information options with specific routes to the adjacent infrastructure links. If it's a thread network, then we're not using RAs, but basically the same principle applies. So, so that's basically the idea of how routing works. So this is not like a routing protocol. We're just using router advertisements because we're just talking to adjacent links. We're not doing anything fancy. It would be nice to enhance this with Babel, but this basically works. So the next step is let's see. Oh, right. So I talked earlier about DNSSD. So all of that functionality is required in order to provide discoverability of devices on the stub network from the adjacent network. One thing I didn't mention in the slides is that stub network devices also may need to discover devices that are on the adjacent network. And the adjacent network being a Wi-Fi network, it's your home network usually, right? So those devices are going to be advertising using multicast DNS. And that means that we need a DNSSD discovery proxy as well in the in the stub network router. And by the way, all of the stuff that I'm talking about is already in the stub network document. So if you're totally lost and you can read the document, and I think it's pretty clear. But anyway, in order for devices that are on the stub network to discover devices in the home network, they need to be able to send DNS queries to the discovery proxy, which can then send DNSSD queries out on the home network to get back the answers that are returned to the DNSSD client on the stub network. So that's an additional piece of functionality. The reason I don't mention that in these slides is because that work is completed. We already have DNS push. We already have the discovery proxy. Those are both RFCs. So there's no further work to do on that. It's just something that needs to go into a stub network router. So can we go to the next slide now? I'm almost done, honest. So one of the issues that we have, and I alluded to this earlier, is that we need to be able to, if we want to be able to do full mesh routing, we have to have prefixes that are valid on the network. So like the stub router can generate a prefix, a ULA prefix, and use that on a link that it's directly connected to, and that works, right? But if we want routing to links that the stub router is not directly connected to, we have to have a real IPv6 address. It doesn't have to be a GUA. It could be a ULA, but the ULA has to come from the infrastructure, not from the stub router. So the infrastructure knows how to route the ULA if it is ULA. If it's a GUA, that's great too. It just needs to be able to route that. So so we need a solution for prefix delegation, and right now we don't have one. DHCP v6 sort of gives us what we want. HNCP sort of gives us what we want. The problem is HNCP is doing a bunch of stuff we really don't want for stub networks. We don't want HNCP to be blasting out multicast packets on the stub network. That's a really bad idea. It's never going to reach anything. So we would need to have a profile for HNCP if we used HNCP. And similarly, we would need extensions to DHCP v6 if we use DHCP v6. These are open questions. And also, if we use DHCP v6, we need some way to cooperate. Because there might be multiple stub routers that all need the same prefix for the same stub network. How do they all know about it? How does that get into the routing infrastructure? That's an interesting problem, an unsolved problem. So this is something we could work on. Another problem is, suppose we've got a CE router that supports DNSSD, supports supports delegating browsing zones. How do we actually tell it what browsing zones to delegate? There's two solutions here actually. One is we could just put an SRP server in the CE router, and then the stub network devices could discover the SRP server that's in the stub router, and then they could just forward SRP requests straight to the stub router. And now those devices are all discoverable using DNSSD without any multicast traffic at all. That's one way to solve the problem. Another way to solve the problem is to keep the SRP server and the DNS zone in the stub routers, but have a delegation from the CE router. So either way we solve that problem, there's new text to write. And it's probably text that needs to get written in HomeNet or some equivalent working group, I think. I suppose it could be done in DNSSD also, but it seems HomeNet relevant because we're talking about customer edge routers in a multi-subnetted home, and that seems like home network. And then how do we eliminate all of this excess multicast DNS traffic? Because we're starting to, if we're going to really leverage all of this service discovery stuff, we're going to start to see more traffic. Multicast traffic is already a problem. It slows the network down. It's not reliable. And so, one way to do that is to just have the stub router intercept all the multicast, or sorry, have the customer edge router or have the Wi-Fi access point intercept all of the multicast traffic. So when you get a multicast DNSSD multicast, an MDNS multicast from a client on the Wi-Fi network, it's just consumed by the access point, which then forwards it to a discovery proxy, which sends back the answer. If we need to discover devices, we can use MDNS, but it's not really multicast. We're just sending MDNS to each host. And then if that host has one of the services, it will reply with a unicast reply, which it thinks is a multicast reply, but remember, we're intercepting the multicast. So we can basically eliminate all of that multicast traffic from being actually transmitted as Wi-Fi multicast traffic. This again seems like something that would make sense to discuss in HomeNet. So those are other topics that I think would be worth working on in the future. That's pretty much what I have to talk about. We can go to the next slide that has the list of drafts. And you can talk to me about this, and you can talk to Stuart about this. And there are a bunch of people in OpenThread that you can also talk to about this. But Stuart and I are kind of the main co-conspirators, so talking to us would be good.
Thank you, Ted.
Mm-hmm.
That was actually really cool. Okay, so first I'd like to open up the queue for technical discussion on all of this stub network topic. I have seen a little chatter in the chat. Would anyone have additional questions or comments?
I noticed that Una asked the question about what I mean by full mesh routing. Do I just mean routing? the reason I'm drawing that distinction is because we're sort of doing routing with RAs, which is not really a routing protocol. So I say full mesh routing just to distinguish between, like, sort of routing with RAs versus actual routing. So yes, I do mean routing.
Stuart?
Yeah, the thing I would add to that is the distinction. When Ted and I talk about full mesh routing, we mean multiple hops within the home network. And what Ted is talking about here with the stub networks is a simplified form of that, where you assume that the home has one current Wi-Fi network, which is, in a sense, the backbone network. And you may have multiple stubs hanging off that backbone, but it's not an arbitrary topology of interconnected links. It is a backbone with some number of stubs hanging off it. And part of the complexity Ted's talking about is some of those stub routers might serve the same stub network. So that's where some coordination is needed, because you want multiple stub routers for reliability, but you don't want them to step on each other's toes. So this is intentionally a simplification of the problem statement, to not try to do a full multi-hop network in the home, but to have a two-tier hierarchy with a backbone and stubs hanging off it, but not stubs hanging off stubs ad infinitum.
Okay. Is there further technical discussion? If not, we'll launch into the administrative discussion. Oh, Eric?
Yeah, so Ted, first, without any head at all, looks like a cool stuff. Honestly, I didn't read your slides. That's one thing I will do over the weekend for sure. Looks nice, simple ideas. Now, putting back my AD hat, just curious about the intended status. Do you think it could be more like a best common practice for this document? Like, so you don't produce any protocol, right? That's my understanding. So it's only advise and BCP.
Yeah, it's really on the edge, because for one of the things we want is to avoid having the stub router step on the home network, right? We don't want the stub router to be adding a bunch of stuff to the home network that isn't needed. And in order to avoid doing that, we need a state machine to track what's happening on the home network. So in a sense, that state machine looks an awful lot like a piece of protocol work. But yeah, this is really more in the line of best. This particular the Stub Networks document in particular, I think, the reason I call it BCP right now and why I think that's maybe the right name for it is because really it's mostly, here's what you do with RAs, which we already have a protocol spec for. Here's what you do with DNSSD. We already have these protocol specs, or we're working on these protocol specs. So in that sense, it does make sense to call it a BCP, and I think that that's a question that we should answer. It may be that the right way to do this is to have a BCP and then actually have a little document that just talks about the state machine. That's a standard document.
Okay.
So,
now go on, Barbara.
Oh, go ahead.
No, go.
I was just going to say, as someone who is involved in all of the CE router documents, actually what I was thinking was that what you're describing sounds rather like a device profile type document, which has often been published as informational.
Then we can't say must and should.
Oh no, we have no problems with musts and shoulds in informational. Those can be all over the place in informational drafts. Trust me.
It's not to my taste personally, but okay. Again, no, on this one, no head at all. Now, other questions. The Open Thread group, does it produce specification?
No, the goal is to have this be a specification of the IETF. And by the way, I mean, one thing that I would like to emphasize is that although this is shipping in products, because it's sort of just advice about how to do stuff, if we change the advice a little bit, I don't think that would be a bad outcome. Like, we're not wedded to doing it exactly the way we're currently doing it. So this is not like, please rubber stamp this IETF. This is, let's work on this, let's look at this, let's critique it, let's change it if we need to.
Okay, that was basically my next point. And my last comment, it's way too early to decide, of course. For sure, it's not for IoT ops. I'm not sure, though, it's in HomeNet. We will need to check the charter based on the content. Of course, we can start working here, right? So like every community in the IETF, that's for sure. HomeNet was very specific. It's linked somehow in the mindset of many people to HNCP. And maybe it could be wise, and again, it's way too early. And maybe I'm moving my head on this one. It's way too early to link this to HNCP. Maybe another group and dissociate HNCP from your IDs could be better on the long term. Again, a little bit too early, right? But just put the question in your mind.
I mean, I will say that I think this document is ready for adoption in some working group. So in that sense, perhaps it's not quite as early as you're suggesting. But yeah, I agree that if we think HomeNet is really all about HNCP, then it probably isn't the right place. That's an open question to me. I mean,
Absolutely.
for me, HomeNet was about the multi-subnet routing problem, but it really depends on who's showing up, right?
Yeah, but maybe your document is ready, right? So it's not about the quality. But again, I'm not sure whether it's good idea to link both together. I mean, you said it, right? Somehow it's disappointing, but HNCP is not deployed.
Yeah. I mean, I think, you know, one suggestion that I would have is that this is something we could discuss on the working group mailing list. And if it basically just falls flat, then it's probably not a good idea, right? We probably shouldn't do it at HomeNet. If nobody answers questions about it, if nobody wants to talk about it, we shouldn't do it at HomeNet. But, you know, if there's interest in doing the work, I mean, I think that, you know, there are some experts who are not normally attendees at HomeNet who would hopefully show up if we did it at HomeNet. If we did it in V6 Ops, maybe those experts would already be there. But the problem is if we do it in V6 Ops, then we just have like, it's the anything working group. Yeah, this isn't really anything spec.
I won't comment on this, right? But routing working group, for instance, routing area working group would be also an interesting part.
Maybe.
Thank you.
Yeah.
This is Stuart. I want to add something. Eric, you asked a question, and I want to make sure we give you an accurate answer. You said, does the thread group produce specifications? And the answer is yes, it does, for things that are specific to thread. And one possibility is we could do this work just within the context of thread. The reason we think that's a bad idea is because it's applicable to many different kinds of networks, not just thread. So we don't want it to be pigeonholed. We want to work with the IETF to find the right ways to solve this. And thread will be a beneficiary of that, but not the only one.
Yeah. And basically, when I was asking the question, it was basically whether we will receive the specification from thread and you put the IETF stamp on it. So it's not the case. And I do agree, it seems to go at least to be something much wider than plain thread. So fully agree on
this is exactly why Ted and I are encouraged people currently engaged with thread. We've encouraged those people to understand how the IETF works and get involved, because we think the IETF is the right venue for this work.
By the way, just a slight clarification. Eric asked about OpenThread, and Stuart, you answered about the thread group, and they're actually two different things. But you know, that's a good point. There is an organization that does specs for thread. That's the thread group.
Stephen?
Yeah, so I mean, I think this is pretty cool stuff. I would like to see it happen in the IETF somewhere, and HomeNet might be a place. I don't know. It's not a huge deal if it is or isn't. But I guess the question I have is how many other people are interested in working on this? That's the one I'd love to get an answer to, which we might not get today for sure. We raise on the list, of course. But I'd really love to know from the there's 40 people in this session. How many people, if there are people here who are interested in this work or helping with it, seeing it happen, you know, those expressions of interest now could be quite useful in terms of figuring out what to do.
I'll put together a poll on that. I thought we had another person in the queue, but
Esco was in the queue.
yeah. Did you want to? Okay. While he talks, I'm going to put a poll together, and we'll see what sort of interest we have.
Yeah, I think what I wanted to say was just a clarification indeed, like Open Thread, that's the open source software project. It does not make any specifications. There's the thread group who it doesn't make the open source software, but does make specifications, but they're mostly based on IETF specifications. So that's the clarification.
By the way, one thing to say about asking that question is I was planning on getting the open thread people, sorry, the thread group people to come and participate in this meeting, but I just didn't have time this week to arrange that. So one of my goals here is actually to get, because this working group has been a little bit moribund, and that's been a little bit sad to me because I think the work we're doing in this working group is really interesting and useful work, and I feel like we didn't quite make it, and that's frustrating. So I really want to see this working group succeed at what it originally set out to do. And so one of my, sort of evil plans is to get more people involved by pulling the thread group people in to help work on this stuff, because I think it's an area of interest to a lot of those folks as well.
Barbara, I'm not sure if that poll worked.
No, I'm redoing it because I found it was ambiguous the way I put it together.
Ah, gotcha. Good.
Okay, I think this is less ambiguous. And so if anybody hasn't used the poll tool, you should be able to go up to the little icon at the top that looks like a vertical bar graph and click on that and vote on one of the options.
And if people clicking buttons are comfortable to also speak on the topic, that would be welcome too.
Okay, so it looks like out of the 35 participants on the call today, 11 have raised their hand and one has purposefully not raised their hand, which is a no, I'm not interested. And I guess that means the remaining 23 are disinterested.
Or asleep.
There is always that possibility. Okay. So let's sort of then talk about not just this, but also Daniel and Michael's work on the name delegation and how to best get good review of that topic. So maybe let me do another.
Just a clarification. It's not only me and Michael. I mean, they are
And Ray.
text files. So welcome, but I prefer not to.
Fair enough. Y'all are simply the lead authors. That's why I name you. And Ray is also, I think, one of the authors now that's listed. But yeah, so I'm going to just do a poll of if we were to do a WGLC, how many people would review? that is a pretty good review. It's not bad to get 9 raised hands on that sort of thing. Does it make sense, Stephen and Eric, then for us to just go ahead and proceed with a WGLC if this many people are willing to review it here?
For me, yes, it's enough, specifically in a small working group. And now you may want as well to ask the review by the Internet Directorate to get some DNS expertise.
Yeah, so I think it's, if we got nine decent reviews, it would be great. If 9 people are willing today, we may get less than 9. It's possible, but I think it's worth a shot. So yeah, when Daniel and Michael think it's ready, then yeah, we could give it a try and see what happens. And if we don't get enough review, I think then we just pass the problem back to Eric and say, figure out what to do. So yeah.
Thank you.
Okay. Then Daniel, do you think it's ready, or do you think you want one more reb? Your last one was in November.
Yeah, I think we need to have one more update on that.
Okay. Then we will, if you get it in soon, then I think, we can ride this wave of interest. So I would prefer sooner rather than later, and then we can start the WGLC on it.
Okay, worked fine. Thanks.
Okay, so then let's go back to Stub Networks and what to do with that. I think it's been pointed out it's not currently in our charter. Of course, there could be a recharter, which, as Eric pointed out, would be similar to having another WG. So Eric, I'd really like to get your perspective on where you would like to go with Stub Network, since there are a lot of options that are within int area.
So just before we go there, I wonder, these documents are pretty new. I haven't read them in detail myself, so I think we should, whatever we talk about here, we should make that a bit contingent on waiting 3-4 weeks so that people have a chance to read them as well. Yeah.
Absolutely, okay. You are stealing my word. I just basically browsed through it and got the ID. It's way too early to take any decision. I do think it's personally, right, as an individual, I do think it's important work. As an AD, we need to take some more thinking and decide which is the best place, right? That's it. We need to think, basically.
Okay. And so then it sounds like also, Ted, I think it would probably be good for also asking review in other working groups. It doesn't hurt, because it's not a working group draft. It could actually get, commentary from various places.
Yeah, it's actually been mentioned on IoT Ops and I think V6 Ops as well, but we haven't actually formally asked for review yet.
So I guess one thing we could think about is whether, if we give people 3 or 4 weeks to read it, and we could think about organizing a kind of an interim HomeNet working group session where we would try and flesh out more, are people really interested in working on this, and then if there's rechartering or whatever. I don't know if doing it on the is doing this all on the mailing list better, or is organizing a kind of an interim in a month or 6 weeks or so going to be a better way to try and figure out what to do with this Stub Network stuff?
I kind of think both.
Then why don't we have an interim on HomeNet, both on the Stub Networks and, to give the authors of the name delegation a target for having their drafts out, where we can, they can give a brief presentation on what's changed, and we can agree to launch WGLC. That is, have about 10 minutes for that sort of thing, just to give it a push and a date, and then spend time on Stub.
Yeah, I think some kind of date like that tends to get people reading and doing stuff. Yeah, whereas if we try and only do it on the mailing list, it might kind of just wither away again. So, okay.
I see Daniel says deadlines are good. Okay. Okay,
Usually
then
okay, so I guess
we
the
have
action would be on us as chairs to try and do a doodle for 6 weeks each time or something like that.
Yep. That sounds good. Okay, so we're coming close to the end. Are there things that we should discuss that we haven't discussed? I'm not hearing anything. In that case, I'm going to thank Eric and David and Stephen and all of the authors. I think there actually has been good discussion here, and there's definitely good work being done. And I really appreciate all of y'all attending. And I'm looking forward to seeing all of the chatter on the mailing list. So y'all take care. And bye.
So thanks to Stuart for taking notes.
Oh yeah, thank you, Stuart.
You're welcome. I don't know whether, do I need to click save or publish or anything on this? I don't want to lose it.
No, I'll be going in and looking it over, editing it, and then pushing the publish.
All right. I'll leave that in your hands then. Thanks, Barbara.
Thank you.
So Barbara, was that you volunteering to do the minutes?
That was Stephen and David.
You're great.
Okay.
All right. Cheers.
Bye, y'all.
Bye, y'all.